Dear students, welcome to today's class. So, last class we have seen some various types of functions we have seen. Now today some more functions we are going to see. Actually these are very important functions. Particularly first three functions of modulus function, greatest integer function, fractional part function, signum function, explicit function, implicit function, periodic function. Okay now. Particularly this modulus function, greatest integer function, fractional part function and this periodic function. These are very important functions. Why? Because they are very importance is also there in calculus part, in the calculus part while finding the limits, derivatives, there you will get greatest integer functions you will get. So I am going to explain about these functions. So now I am going to explain about these functions in a graphical way. Okay na? So let us see one by one. Dear students, let us learn about this modulus function. Sometimes we call it as a absolute value function. So why this function is necessarily defined is, for suppose it is a number line, here 0 is there, here the numbers are there 1, 2, 3, the left side is -1, -2, -3, so on. We know the system of number lines. For example, 1 is there, 1. It is right side of 1. Here -1 is there, it is the left side of -1. Now if you see the distance, how much distance is 1 from 0? We call it as 1. How much distance is there -1 from 0? This is also 1. Here we are saying the distance here, that's why the distance is always either a 0 or a positive quantity. Okay now, right. How much is the distance? How much distance between from 0 to -3? Here the distance of -3 from 0 is 3 units. That is denoted as minus modulus of -3, that is equal to 3. So like that also, if it is a modulus of -3/2 means how much? 3/2. That means the distance of -3/2 from origin, so from 0 is 3/2. So that is the basic idea to define modulus of a function. From this what can you say? So even it is a distance, it should be either 0 or a positive real number. Okay now, right. Now the definition of this modulus function or absolute value function is given as modulus of x is equal to, whenever you are taking x is a real number, that real number should be either less than 0 or is equal to 0 or greater than 0. Either it is a negative or 0 or positive. If it is a negative, the modulus of x is equal to -x. Don't get confused here. Sir, you are saying all positive value only. No, but you are getting here -x means already x is negative here. Already negative. Negative of negative will become positive. That is modulus of -3 is equal to minus of -3, that is equal to 3. Understand? So if it is 0, 0 means what? What is the distance between 0 and 0? 0 only. That's why 0. X greater than 0. If x is a positive number, modulus of x is equal to x only. What is the distance between 2 to 0? 2. Distance between 3 to 0? 3. Okay now? Now let us draw the graph of this modulus function. Okay now? The graph of this modulus function is, see here. So this is a real number x-axis and it is a y-axis. Let it be origin 0. Now, so here numbers are 1, 2, 3, 4. So this side -1, -2, -3, -4. This is also 1, 2, 3, 4, 5. So this is -1, -2, -3, -4. So this is a two-dimensional plane. We know that. So if what is the modulus of 0? 0. What is the modulus of 1? 1. Modulus of 2? 2. Modulus of 3? 3. Modulus of 4? 4. Modulus of -1? 1. Modulus of -2? 2. Modulus of minus 3, 3. Modulus of minus 4, minus 4. So, if you join all these points, what you will get? You will get a V-shaped figure. And if you observe this line, this major line is no. So, this is 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 means what? What is the slope of that line? It is a 1. Therefore, the slope is 1 means this is 45 degrees. Understand this? So, this is a, and one more thing is this angle is 135 degrees. Right. So, this branch of this graph is, we call it as y is equal to x. This branch is y is equal to minus x. That also should be carefully observed here. So, here this branch we call it as a two branches. One branch is from 0 to this side, right side, that is making an angle of 45 degrees with x axis. And another branch is making 135 degrees with the positive direction of x axis. Therefore, its slope is tan of 135 degrees is minus 1. Therefore, another branch is y is equal to minus x. Understand this? So, this is the graph of the function. From this, what can you say? X is here, the x takes the real numbers. But if you observe what is the y value, y takes only the positive real numbers. 0 and positive real numbers. So, this is a y value. 0 and positive real numbers it is taking. That is why the domain is input you can give, any input you can give. In place of x, any input you can give, rational numbers, irrational numbers, integers, fractions, whatever may be the input you can give. But the output is always either 0 or output means y value, out means y f of x value, from 0 to infinity. The more the input value you give, the more output value you will get. Understand this? So, this is the graph of the function modulus of a function. So, this is also called as absolute value function. Now, we are going to see some very, very important basic properties of modulus function. Okay, na? So, let us see that. Dear students, so we are going to see some properties of modulus of function. Okay, right. So, x square is same as modulus of x whole square is same as mod x square. Understand? So, this is a property very, very important. Mod x whole square is same as modulus of x square, same as x square. Okay, na? Right. Second one, modulus of x into y is equal to mod x and mod x times mod y, mod x into mod y. That means you can separate modulus for both the things. For multiplication and division also the same thing. You can separate the modulus from numerator and denominator separately. Obviously, since y is in the denominator, y cannot be equal to 0. That is a well-known fact. If modulus of x is less than or equal to a, then x value should be minus a to a, x lies between minus a to a. So, very, very easy thing this is. For example, you can see the proof for this also. For example, modulus of x is equal to a. So, a is a real number. For example, modulus of x less than or equal to 2 means, so your number is 2 here. Okay, now, right. So, here 0, you can see, take it as a 0, 2, here minus 2. So, whatever may be the values you can substitute between minus 2 to 2, minus 2 to 2 including minus 2 to this inequation will satisfy. For example, if you substitute 0, modulus of 0 is less than or equal to 2, right? If you substitute 1, modulus of 1 is less than or equal to 2, right? So, whatever may be the values in lies between minus 2 to 2, that equation will satisfy. Okay, now, if you take more than 2, if you take 2.5, modulus of 2.5 is 2.5, is 2.5 cannot be less than or equal to 2. So, these values are not satisfying. These side values are not satisfying. That is why if modulus of x is less than or equal to a, so your x value, here x value input should be lies between minus a to plus a. Okay, now. So, now coming to this modulus of x greater than or equal to 2. That means, for example, if modulus of x is greater than or equal to 2 means, what are the x values you have to take to make that inequation right. So, that is equal to, see here. So, this is a 0, this is 2 and it is minus 2. If you observe clearly, if you take the values from minus 2 to plus 2, this inequation cannot be satisfied. Inequation cannot be satisfied. If you take more than 2 here, less than minus 2. If you take more than 2 here, more than 2 here, more than 2 here, less than 2, this side, this side. Minus 3, modulus of minus 3, 3, 3 greater than or equal to 2, right. Modulus of minus 4 means 4, 4 greater than or equal to 2, right. This side 5, modulus of 5, 5 greater than or equal to 2, right. Okay, na? So this is also very easy. Now coming to modulus of x plus or minus y is always less than or equal to mod x plus modulus of y. Modulus of x plus y is always less than or equal to mod x plus mod y. If xy is greater than or equal to 0, the product of xy is greater than or equal to 0, then it is strictly equal. Modulus of x plus y is equal to modulus of x plus modulus of y. Similarly, the eighth property is also like this. Modulus of x plus y is greater than or equal to modulus of x minus modulus of y. For all these things, proofs are there. Proofs are very there, but they are not that much important for JEE mains preparation point of view. But the results are important. So these results are very important. Okay, na? Right. I hope that you understand this modulus function and its definition and graph and properties of this function. Okay, so we will do number of problems are there. So in the future course we will do number of problems on modulus function. Okay, na? So let us see the next type of function. Dear students, one of the very important function is step function or greatest integer function. Sometimes it is called it as GIF, greatest. In short, in some problems in examinations, sometimes they will put it as a GIF, greatest integer function, or sometimes it is also called as floor function. So before explaining this function, so I will proceed like this. So let us take an integer, any integer 5. Okay. Now tell me the integers which are less than or equal to 5. The integers which are less than or equal to 5. That means I will write it on a number line. So this is equal to 0, 1, 2, 3, sorry. So this is a 1, 2, 3, 4, 5, 6, so on. Now tell me the integers which are less than or equal to 5. Which are less than or equal to 5 means what, and 5 and less than 5 means what are the integers you will get, so on, 0, 1, 2, 3, 4, 5 also less than or equal to 5 I am telling. So on from this side, so on 0, 1, 2, 3, 4, 5 up to 5. Understand this. Now in this, which is the greatest one? Which is the greatest one? Greatest one is equal to 5. Greatest one is equal to 5. So this is called step of 5 is equal to 5. Okay, na? Now the next example what I am going to tell is, let us take 4.8. So 4.8 will be here. So that is equal to 0, 1, 2, 3, 4, 5, 6, 8. 4.5 will be here. 4.8 will be here between 4 and 5. Tell me the integers which are less than 4.8. 4.8 integer means what? So on 0, 1, 2, 3, 4. Up to 4 only. Why? Because 5 is greater than 4.8. So now tell me the integers which are less than 4.8. In this greatest one is, what is the one? It is a greatest one, 4. Therefore 4.8 is equal to 1. That means what? So that means what? The 4.8, the integers which are less than 4.8 in that greatest one. In that greatest one is 4. That is 4 mod. So this is called step of 4.8 is equal to 4. Okay, now coming to the negative direction. For example, if it is minus 2.5, let us see what happens. Step of minus 2.5. Draw a number line. So here we can take this is a 0 and it is a minus 1, minus 2, minus 3, minus 4, minus 5. Minus 2.5 means where? It between minus 2 to minus 3 here. Okay, right. This is the here. Now tell me the integers which are less than minus 2.5. Less than or equal to minus 2.5. Less than or equal to minus 2.5. So what are the integers? So on minus 5, minus 4, minus 3. That's all. So on minus 5, minus 4, minus 3. These are the integers which are less than. So all these numbers are less than, no, this side. In this, which is the biggest one? Minus 3. That is equal to minus 3. So from this, step of minus 2.5 is minus 3. Step of minus 2.8 is minus 3. Step of minus 1.2 is, that is minus 0.5. That is equal to minus 1. Step of minus 3 is minus 3. Understand? Step of minus 7.8 is minus 8. If it is minus 7.8, minus 8. If it is simply 7.8 means 7. If it is simply 7.8, it's 7. Step of minus 4 is minus 4 only. Understand? Step of minus 4.5 is minus 5. Understand means? Understand these step functions? Very simple, very simple. Okay, now let us see some properties of this, very important properties of this greatest integer function. Okay, now friends, before going for properties of triangles, so first see the graph of greatest integer function. Okay, now right, let us see that. First start with 0. Okay, you start with 0, right? What is step of 0? 0. What is step of 0.5? 0, 0.2, 0, 0.3, 0, 0.0, 0.1, sorry, 0.9, 0, 1, 1 only. So up to here it is 1. Okay, now step of 1 is 1 only. That means here it breaks up to here only. Up to here only. 0.9 is 0 only. 0.99 is also 0. What is step of 1? 1. Here it starts. 1. What is 1.1? 1. 1.2? 1. 1.3? 1. 1.999? 1. It is 1. Up to here 1. What is 2? So here break will come. What is 2? Step of 2 is 2. Step of 2 is 2. Understand? What is 2.1, 2.3 for all this is 1. Again, what is step of 3? Here break will come. Step of 3 is 3. So from here again break. Step of 4 is 4. This is. Understand this? That means this function is discontinuous at 1, 2, 3, 4. At the integers it is discontinuous. Now coming to the negative directions, let us see that. Step of minus 0.1 is how much? Minus 1. So here minus 1. So this is a minus 0.1, that is minus 1. So if you take it is a minus 1. So this is will come here, again here. So again from come here. So again here. So this is what to say here. What is the nature you are observing here? What is the type you are observing here? All are in the steps, no? Just like steps. That's why this is called step function or greatest integer function. From negative direction also you can say. From this graph, what can you say? Domain is the domain of this function is set of real numbers. Any input you go, but the output range is always an integer, I or z. Okay, na? Range is always an integer. Okay, so this is the graph of the step function. Okay, now let us see the properties of greatest integer function. Let us see some properties of greatest integer functions. So step of x plus n is equal to step x plus n, where n integer. Okay, so very important. So from this we can conclude that wherever if you get step of x plus 2 is equal to step x plus 2, you can write down. Step x plus 2 you can write down. So wherever if you got x minus 2, step x minus 2 you can take it. Just to remember that this is an integer only, then only you can separate step. That means if it is a step of x plus 1 by 2, you cannot write down, plus 1 by 2, you cannot write down this. Only if it is an integer, plus 2, minus 2, plus 3, minus 3, 6, 7, 8, 9 like that, then only you can take out that integer from that step. Okay, now right. It is also very, very important. So, step of x is always lies between x minus 1 and x. Step of x value is always lies between x minus 1 and x. You can take a number of examples also. But remember here this, afterwards you learn this property, Step of x is lies between x minus 1 and x, whereas x lies between step x and step x plus 1. Comparatively, these two study. Comparatively study this. Okay, now, right. Step of x plus step of minus x is equal to 0 if x is integer, minus 1 if x is not an integer. Very easy. Take any number. This is step of 2 plus step of minus 2. This value is 0. Why here? 2 is an integer. 2 minus 2 are integers. If it is not integer, you are getting minus 1. That means what? Step of 2.5 plus step of minus 2.5 value. Step of 2.5 is 2. Step of minus 2.5 is minus 3. That is equal to minus 1. You are getting minus 1. That means if x is an integer, it is 0. If it is x is not an integer, its value is minus 1. Right, it is an inequality. Step of x plus y is always greater than or equal to step x plus step y. Step x greater than or equal to k, that means x is greater than or equal to k. Step of x less than or equal to k means x is less than k plus 1. Step x greater than k means what? X greater than or equal to k plus 1. So, this is also step of double step. Step of step x is equal to step x. This is also one of the important formula we will come across in while solving the problems. So, that is a step of x plus n plus step of x plus 1 upon n, step of x plus 2 upon n, so on, step of x plus of n minus 1 n, that is equal to step x. Understand this? So, from this you can easily say that, so wherever you will get what is the value of x by 2, step of x by 2 plus x plus 1 by 2, x plus 3 by 2. So, this is nothing but step x, simply step x. Okay, now, so not up to here only, sorry. Its value is step x. So, here if it is n, n minus 1. If it is a 2, 1, stop. Therefore, its value is step x. Understand? So, step x by 2 plus step of x plus 1 by 2 is equal to step x. Simply step x. Okay, now, right. So, I hope that you understand these properties of greatest integer function. So, once you revise all these properties, once you write it on a book and revise all those properties, so that this will be useful while solving the problems. Okay, now. So, let us see the next type of function. Dear students, let us see this explicit function and implicit function. Very easy. Explicit, implicit. So, just I will give some examples, then you can easily catch the definitions. For example, y is equal to x square plus 2x plus 3. Otherwise, x is equal to y square plus 2y plus 3. Otherwise, y is equal to sin x plus 2x plus 3. Now, these are called explicit functions. That means the independent variable x, the dependent variable y can be expressed in the form of an independent variable x. That means what? Explicit means what? If you are able to separate x and y separate, then they will become an explicit function. Quite opposite implicit function. For example, you see x square plus 2xy plus y square minus y plus 2x is equal to 0. Can you separate x and y separately? No, you cannot write. Can you write down it, that equation as y is equal to x or x is equal to y? No. For example, xy plus sin of xy is equal to 0. Can you separate xy plus sin xy as x is equal to or y is equal to? Can you write it? No, you cannot write down. Such type of functions are implicit functions if you are unable to express one side x, another side is y. If you are unable to separate it, then that is called implicit function. You cannot separate it. You cannot separate it. You can separate. You can. So this is a x. This side y. If you are able to separate it, so then that is called an explicit function. Explicit, implicit. Explicit, that means you can separate. Implicit means you cannot separate. But in our course of time, so in our discussion, almost all functions are explicit only. Y is equal to, y is equal to, y is equal to, all are explicit function only. Okay now? So I hope that you are able to understand this concept. So let us go for next concept. Dear students, let us see this periodic function and linear function. Very, very easy concept. Periodic function means what? Let us take f of x is any real function. If there exist a t is a positive real number. Positive. If there exist t a positive real number such that f of x plus t is equal to f of x, then that function is called a periodic function and the value t is called fundamental period. Fundamental period. Okay, now just I give one example. For example, f of x is equal to sin x. Then what is f of x plus pi, 2 pi? That is sin of 2 pi plus x. That is again you are getting sin x, that is equal to f of x. That means f of x plus t is equal to f of x. In place of x, if you substitute x plus 2 pi, then you are getting same function. Then this 2 pi is there now. This is called period of the function sin x. Period of the function sin x. For cos x also 2 pi, for tan x it is pi. Okay now, why it is tan x? So f of x, call it as tan x. Okay, f of x plus pi, that is equal to tan of pi plus x. So this is equal to, again you are tan x, that is equal to f of x. That means it's a least value, least positive real number pi. That's why that pi is the, actually you can write down 2 pi is also, you can write down 2 pi also, but pi 2 pi, which is the least one, pi. That's why pi is the fundamental period of tan x. Okay na? So very, very easy definition this is. Now here also there are so many properties are there. Now coming to linear function, yes, very, very important, very, very easy. If f of x is a function of the form ax plus b, that means where is the degree of x is 1. This is called linear function. F of x is equal to 2x plus 3, 7x plus 5. All these are all called linear function. That means any function of the form f of x is equal to ax plus b, where a and b are real numbers and x is a variable. The degree of the variable should be 1. Then only that is called a linear function. Why we have to call it as a linear function? If you draw the graph, you will get a straight line. If you draw the graph of y is equal to 2x plus 3, y is equal to 7x plus 5, you will get a straight line. That's why we call it as a linear function. Straight means linear. Understand this? So I hope that you understand these two functions. Okay na? Right. Dear student, what is a fractional part of x? This is a fractional part function also we can take. What is the definition of this? Means if x is any real number, the fractional part of x is denoted as x minus step x. X minus step x. This is a fractional part function and it is denoted as like this, or flower x, flower bracket x. So on the whole, flower bracket x is equal to x minus step x. This is called fractional part function. Let me give one example. What is the fractional part? 2.7 means 2.7 minus step of 2.7. This is equal to 2.7 minus 2. This is equal to 0.7. Understand this? So what is the fractional part of 2.7 is 0.7. Right. So if it is fractional part is 2.3, fractional part of 2.3 minus 2.3 is minus 2.3 minus step of minus 2.3. So this is a minus 2.3 minus step of minus 2.3 is how much? Minus 3. That is minus 3. That is minus 2.3 plus 3. Minus 2.3 plus 3. So this is equal to how much from if you subtract 2.3, this is a 0.7. So this 0.7, so that means for 2.7, 0.7, for minus 2.3 is also 0.7. Understand this? So for example, any number, for example, fractional part of 5 is 5 minus step of 5, that is equal to 0. Understand? So fractional part 5.2 is 5.2 minus step of 5.2, that is equal to 5.2 minus 5, this is 0.2. Understand this? So this is the definition. For example, fractional part of minus 3.4 is, that is a minus 3.4 minus of step of minus 3.4 is minus 4, it become plus 4. So this is equal to how much? 0.6. 0.6 is your fractional part of minus 3.4. Okay now? So this is a definition, that means x minus step of that value, x minus step of x, that will gives the fractional part of x. Okay now? So I hope that you understand this concept. Dear students, I hope that you enjoyed today's class, and we will discuss the various types of functions in today's class. In the next class, so we will do many number of problems based on this function. Okay na? So until then, all the best.